The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseWare continue to offer high-quality educational resources for free. To make a donation or to view additional materials from hundreds of MIT courses, visit MIT OpenCourseWare at ocw.mit.edu.
Welcome to 3091. My name is Donald Sadaway, and I'll be your lecturer this fall. Got plenty of room here. If there's need to sit, you can sit on the steps and in the aisles, and we'll get things sorted out in the next day or two. What I'd like to do today is to introduce myself, introduce the subject, introduce my plans. I have plans for you. I have plans for you, called Plans for Learning, because that's what it's all about. People, if you're coming in now, if you can come sit up here, and you can even sit on the floor up here. It's one big happy family. So let me begin by telling you that 3091 is the most important subject you will take at MIT. It is the most important subject you'll take at MIT. I truly believe that. But you know, any professor who stands before you should say the same thing about his or her subject. If they don't believe that, they shouldn't be teaching. The difference is when I say it, I'm right. It is the most important subject. I'm going to teach you things that you're going to retain. You're going to take with you. So we need to get down to that. What I want to do is get you to appreciate the unique perspective that you'll get from studying solid-state chemistry. And so what I want to do is begin by doing a little bit of introduction so you get to know what's going on. So I'm going to talk a little bit about myself, about the staff. And actually, if I could ask the teaching staff to start handing out, there's 3 handouts going to come to you. And just stay seated. We'll get them to you. If you don't get them, there's plenty of copies after. And we're going to post everything on the website, so no need. So let me begin by doing a little bit of background so that you know what's going on here. I was born in Canada. I went to the University of Toronto, and I studied chemical metallurgy. Chemical metallurgy. You might say, well, what's the person who studied chemical metallurgy doing teaching chemistry here? Well, after my PhD, I came here as a postdoctoral fellow in 1977. The plan was to stay for a year or two, then go back to Canada, and I lost track of time. So I joined the faculty in 1978, and my first teaching assignment was 3091 recitation. I had 2 sections. One met at 8 a.m. and one met at 9 a.m. We don't have 8 a.m. sections. At least we haven't in recent years. Maybe it's time to revisit that. So my research is electrochemistry. That's why I'm teaching chemistry. Electrochemistry is the most important branch of chemistry. Why not? Find your passion and pursue it. So I'm interested in non-aqueous electrochemistry. I don't care about water. I'm interested in non-aqueous electrochemistry. So molten salts and polymers. The applied research, first of all, interested in environmentally sound technologies for extraction, refining, recycling of metals. It's all chemical processes. All right. Second is batteries. I want to have an all-electric vehicle in my lifetime. I want to see the end of the internal combustion engine applied to personal mobility. The only thing that stands between us and that is a suitable battery. So find an important problem. Work on it. To say nothing of the wireless device there. She's driving and she's talking on the cell phone and looking at the photographer. And the last one, you know, we have to dream. We have to dream beyond the day-to-day living. let's talk about the stars. So if we're going to go to the moon, we're going to go to Mars, we want to be able to produce oxygen, structural metals, and photovoltaic materials from in situ resources. So I have some research on that as well. So that's kind of stuff, a little background about myself. So now let's talk about the perspective of 3091. All of this will be posted. You can take notes, you can just enjoy. Don't have to worry about getting tested on this material, at least not on my life story. That wouldn't be, it'd be too self-serving. So if you look at any engineering system, the performance of that engineering system is a function of its design and its construction. And that could be anything from a computer to a living system. We are solid-state devices. We're made of soft matter. This is macromolecular chemistry. These are photodetectors. Band gap 2 electron volts, respond to visible light, but they're not made of gallium arsenide. They're made of organic matter. The same rules, the same laws of chemistry that apply to what makes this laser glow green apply to what makes these photodetectors work. Well, what about construction? Construction is a combination of workmanship and choice of materials. You take this computer, if I pull the silicon out, I replace it with gallium arsenide, leave everything else the same. Gallium arsenide switches 10 times faster than silicon. All of a sudden, I got a clock speed 10 times faster with no change in design. So that's the power of choice of materials. And why? Properties. Properties. Materials are bundles of properties. Conceptually, they're bundles of properties. What is this? You say it's an aluminum can. No, it's a bundle of properties. This is a beverage container. I could make this out of borosilicate glass. I could make this out of polymer. I could make this out of metal. I could even make it out of steel versus aluminum. I could make it out of titanium if I wanted. I could make it out of gold. I'd prefer to make it out of platinum if I had my way. Why? Bundle of properties. Mechanical strength, chemical inertness, ease of fabrication. That's not a unique solution. Cost. There's a factor that may be a determinant. So, properties. And where do we get properties from? Here. Composition, clearly. Everybody knows that. If you change the composition, you change the properties. But this is different. What I'm going to tell you now is different. What I'm going to tell you now is why you take 3091. The properties are not only a function of composition. They're a function of the instant atomic arrangement. How we arrange the atoms. Same composition. Simple example. 1-inch thick pine board. 1-inch thick plywood. Both made of pine. Both 1-inch thick. Which one has the superior mechanical properties? The plywood. Why? Because the plywood has been sliced into thin pieces that are laminated, cross-grain. So composition alone can't give you the answer to the question, why is the plywood superior to the solid pine board? It has to be the atomic arrangement. The thesis of 3091, and this is where the chemistry comes in, is that electronic structure of the elements holds the key to the understanding. Not just the chemical bonding, but the long-range atomic order. So that's how we get to the syllabus. So here's the syllabus. 2 big blocks. First block, general principles of chemistry, and that's the same whether you take 3091 or 5111, 5112. This is your insurance policy. This is what ensures that if you take 3091, you can go on later and take 512. You could be a chemical engineer. You can go to medical school. Okay? And then this is the specialty topics that pertain to the devices, engineering systems. So let's turn to the handouts now. What I'm going to do for about the next 15, 20 minutes is just tell you what the class operation is like, so that everybody knows. I want you to understand what you've signed up for. The text is the one shown here. It's out in second edition. It's available at the Coop. It's available at Quantum Books. There's even some first editions out there which are very, very similar. There's some minor differences. There's some numbering differences with some of the homework problems. I don't care if you buy the book. I don't work for Wiley. I don't own shares in Wiley. I don't own shares in the Coop. I don't care if you buy the book. If you want the book, that's the book I use. Lectures. Lectures are Monday, Wednesday, Friday at 11 or Monday, Wednesday, Friday at 1. The enrollment, as last time I looked, is an even 600. So the registrar's computer divided you between this 11 o'clock lecture and the 1 o'clock lecture. If you want to change lectures, please go to Hillary or Lori and arrange it. Because, as you can see, some people don't have a seat. If everybody goes to the assigned place, there will be a seat for everybody. So out of courtesy, I think it's important that we follow the assignment. So if you want to go at 1 o'clock, you're welcome to do so, but please arrange it with my assistants. The 1 o'clock lecture is a smaller group. It's about 150, and it's around the corner on the first floor, building 6120. So 11 o'clock will be in 10250, and 1 o'clock will be in 6120. So that's Monday, Wednesday, Friday. And that's the standard lecture format. I talk, you listen. Okay? I'm going to write things on the board. I'm going to post things up on the screen. So, where you get a chance to interact on a greater level is in the recitations. The recitation is an old, archaic New England term. If you go back to the colonial times, education would be conducted in an unheated room by someone who basically hates children and would come into the room and look at someone and glower and yell, "Sat away! Stand and recite." I would recite the Articles of Confederation. I would rise on my hind legs, quaking in my boots, and I would begin until I made a mistake, whereupon I would be castigated, berated, totally stripped of self-esteem by this monster who would then inflict the same pain on somebody else. That was education in the old days. We're going to do it a little differently this year. Okay? So in your recitation sections, I have asked the instructors not to do that. Instead, you come to class, you control the agenda. I have instructed them not to give you a fourth and fifth lecture. You come there with your questions. You come to my lectures, take some notes. Maybe you don't record everything I say. Maybe you record what you didn't understand. Then you go to recitation. The first thing they're supposed to say is good morning or good afternoon, and then they say, what are your questions? And they drop the agenda. So someone says, I didn't understand what he was talking about at the end of the last lecture when he was doing the Bohr model. I didn't get it. Somebody else said, can you do number 3 on the homework for me? So you drop the agenda. Okay? So those recitations occur Tuesdays and Thursdays. So you'll have a time and you'll go to the same time on the Tuesday and on the Thursday. Same thing applies here as with the lectures. If you wish to change sections, you may do so only with permission of the subject administrators, because it's very important that those sections be kept at a small population. I want to have the population at a number no greater than 20. That way you get good access to the TA. I don't want to have a section with 30 in it. So there are many sections. They run from 9 in the morning through 4 in the afternoon, with multiple sections through the middle of the day, which are the most popular sections. And if you'd like to change, you can do so only with the permission of the administrator. And you have to have a reason to do so. You can't do it because I don't do mornings or because, my girlfriend's in this other section. No. I don't get freedom. I'm told I got to be here at 11, Monday, Wednesday, Friday. I can't go down to the registrar and say, I'd really like to do it at another time. No. No. But if you have a Europ or you have some sports practice or something, we'll allow that. So please stick to the sections. And right now, because of the burgeoning enrollment, we've opened up some sections. So these 3 are underpopulated. So if you'd like to switch into one of these 3, they have very low numbers right now. We've added an extra one at 11, an extra one at 2, and we've added one at 1 o'clock. So If that meets your schedule in a better manner, then again, do it, but only with permission from Hillary or Lori. Oh, by the way, talking about under-enrolled subjects, the complementary subject offered by STS called History, Society, and Solid State Chemistry meets Tuesdays and Thursdays at 11 in room 2136. It is underpopulated right now, so if you're still shopping for a humanities subject, this one bears the precious CIH designation. Think about that. If it's a question about the time of that, then perhaps raise it with the instructor and see if you know, we're talking about a small number of people. I suspect that enrollment is going to be in the dozens, so it could easily be rearranged if the time is conflicting with one of your other classes. Homework. 3091 is different. I give homework as a learning aid. I give homework, and you'll see you have homework questions with model solutions at the outset. I want you to learn by studying the homework. I'm not going to have you work long hours on difficult problems to be submitted and then graded. I don't do that. Part of this is designed to get you to start thinking about the transition from high school to college. What I mean by that is I want you to take ownership of your learning. So I'm not going to come around and say, did you do your homework? And I've got evidence that you didn't do it because you didn't turn it in. So it's easy. It's easy to blow it off. And those of you who had a lot of chemistry, for the first little while, it's going to be a lot of review and you're going to get complacent. Don't do it. Develop good study habits. The homework is a good test of that. Make the time to work the homework problems. But just to make sure, to stimulate interest, every Tuesday in recitation there will be a 10-minute quiz based upon the content of the homework. So if you've worked the homework problems, you'll do the homework quiz handily. If you haven't looked at the homework problems, you might have difficulty with the homework quiz. So there is no homework grade based on turning homework in. The homework portion of your total grade is the aggregate of all of those weekly test scores. And you must take the test. If you fail to take the test, you get 0. And I average the 0 in. If you don't make it to class, contact your TA, your recitation instructor, and you can take a makeup within a week of the time of the original test. I want to give you every chance to get caught up. But it's your education. I want you to take ownership of it. So all scores count. There's no dropping of lowest scores from the average. Some of the other classes perhaps do this. People have actually confronted me telling me it's an MIT rule. I've been here 26 years. I know what the rules are. Okay, speaking of homework, here's homework number 1. So it's assigned today. You've got the model solutions. And there'll be a test in recitation on Tuesday the 14th based upon that homework. Okay? And it's based upon the homework subject. So I don't want somebody coming in with an attorney saying, well, the question looked a little bit like 39, but it's not exactly, well, I think you know what I'm saying. Let's continue with the administration. In addition to the weekly homeworks, there will be monthly tests. Monthly tests, and they've all been scheduled, so you can plan. Okay? The monthly tests are the following dates. September 29th, October 27th, November 17th. The tests will be written in the normal class period. Now, I know you've had all this bonding and orientation period, but you know, I think that it's much better when you write a test for there to be some solid state defects known as vacancies in between the various people. So on the day of the test, we'll have shadow rooms and we'll divide you. So some of you will write in here and some of you will write in some of the other rooms, but you'll write during the normal class period. It'll run the 50 minutes. And likewise, there'll be a test running from 105 to 155, 2 different tests of comparable difficulty. I did this last year, and the difference in the scores on all 3 tests was less than 1%. So I think we're capable of, with the kind assistance of my staff, capable of setting exams of comparable difficulty. But again, you're going to be required to go to the room that you've been assigned. Otherwise, we don't have enough seats or we don't have enough test papers and so on. By the way, on the tests, you will be getting tomorrow these handouts that you can use in working the homeworks. So when you're taking the test, you're allowed to bring in the copy of the periodic table of the elements. We give you a very rich table of constants that's got all kinds of things from the mass of the electron to the speed of light and all this stuff to the requisite number of significant figures. And in addition, you're allowed to take in one sheet of paper, one sheet 8.5 by 11. You can write anything you want on it. Write on the front, you write on the back, you can write on the edge for all I care. All right? You can write, you can print. I've seen students photocopy exams down to the size of a postage stamp. I don't care what you write on there. What it's designed to do is to give you the resources you think you need so that I can focus on measuring whether you've learned anything as opposed to whether you've remembered, memorized anything. Okay? And, of course, something to calculate with. There's a final exam in this subject. It's a 3-hour final. The final exam period is December 13th to 17th this year. Do not plan to leave town until your finals are over. Do not come to your instructor and say, I got a really good ticket, but I'm leaving on the 13th. You're here for the finals. But I will say, once you know your final exams schedule, and you should know that about October 1st. The registrar will publish the schedule. Once you know that, get on the phone, get on the internet, book your tickets. There are 30 degree-granting institutions in the Boston area. They start at different times. They all end just before Christmas. Everybody and his pet dog is trying to get a seat on a plane at a Logan Airport. So once you know your schedule, then you make your arrangements. But you must be here for the final. Grading. For freshmen, it's pass, no record. Pass, no record. And to get a pass as a freshman, you have to be performing at C level or better. For upperclassmen, you get the full range of the alphabet. A, B, C, D, F. It's all there, available for you. What is the final grade made of? I already mentioned homework. Now, this is supposed to be 1/6, but I know I don't want any transcendental numbers here, so I made it 16.75 exactly. So it's roughly 1/6 for the homework. That's the average of all of your weekly quizzes in the recitation. Each of those 3 monthly tests gives also a 1/6. So 1 plus 3 is 4. 4/6, which leaves 2/6 or 1/3. So the final is worth 33%. Right? So that's the breakdown. And the grade is C level, and it's based upon a performance of 50% absolute. I want you to learn. I do not have you compete against your classmates. There is no curving of the grades. Okay? No curving of the grades. How do I know that that's an absolute pass, though? Well, when we set the exams, we set the tests, I sit with my TAs and we say, all right, let's work out the point scheme on this question. Let's say it's worth 10 points. I said, well, let's grade about 5 or 6 of them, maybe 10 of them, get a sense of it. If a person has the basic concept down, regardless of numerical errors, the person has a basic concept down, he or she must get at least 5 out of 10. If the person has not mastered the basic concept, the person must fail, must get 4 or less. And if that's not the case, we redo the point scheme. All right? So if you propagate that through the whole year, and you have the basic mastery of the concepts, 50 is a pass. That's the way we do it. No grading on a curve. But I also look at trends. To show you the kind of attention you get in this class, on the 17th, Friday the 17th, I know where I and my staff will be. We're going to be in a conference room not far from here, and we're going to be reviewing every person's performance in this class. We're going to go down the whole list. And what are we looking for? We're looking for trends. We're looking for trends. Obviously, if your aggregate score is 75, you're passed. But I'm looking at what's going on in the vicinity of 50, because I don't think my point scheme is that accurate. So suppose I have somebody who comes in here with a shaky background in chemistry from high school and gets a failing score on the first test, and works hard and improves but still fails the second test, passes the third test, writes a decent final, and has an aggregate score of 48. I have the freedom to pass that person because I like the trend. Suppose I have somebody else who came here with 2 years of chemistry in high school, got a 95 on the first test, 70 on the second test, failed the third test, failed the final, has an aggregate score of 48. I'll let that person sit there because that person clearly didn't make the investment. That person didn't take ownership of his or her education. That person isn't deciding to be part of 3091 community. In fact, if that person has a 48 and the first person who had the weaker scores has a 46, I can still pass the person with the 46 and fail the person with the 48. If I want to, I can give the person with the 46 an A. I can do anything I want because I'm the professor. What else I can do? There's no requirement for me to fail anybody. My management doesn't ask me what I'm doing in here. Right? They don't know. They really don't. Right? So, if everybody masters the material, I can say A's on the house. They don't say to me, 6 bodies, 1 of them must fail. No. So my point is that I want you to succeed, and I know you can succeed. You know, faculty here have 3 major professional activities. One is teaching, one is research, and the third is administration. We serve on committees. Well, for the last 3 years, I've been chairing the Committee on Undergraduate Admissions and Financial Aid. I chaired the committee at the time you were applying. I read some of your folders. I sat at the selection period where we've got the stacks. 11,000 applications. You went through a grueling screening process. I know the quality of individual in this room. I sat there. It was during the Patriots' Day, no, the President's Day weekend, sitting here Friday, Saturday, Sunday, Monday. Stacks them, go, yes, no, hell no. See, tenure means never having to say you're sorry. So, you're here, 11,000, and you made it. And I know that everybody in this room, first of all, belongs here. Everybody in this room has the intellectual apparatus not to just pass 3091, but to flourish in 3091. And I want you to succeed. The only people who fail 3091 are those who choose to fail 3091. They choose not to come to class. They choose not to work the homework. They choose not to interact with the recitation instructors. I don't know why they make that choice. But the website has all sorts of goodies, including the readings. You got to read before you come to class. I'm not going to write them on the board like a little high school teacher. I'm not doing that anymore. You're taking ownership. So you go to the website. The other thing you'll find on the website are old homeworks, old exams, all sorts of resources, and they're videotaping this. By the way, they're videotaping it in a sort of heightened technology this year, and so some of this is going to end up on OpenCourseWare. So if any of you doesn't want to be, by chance, seen on the internet, then sit out of range of the camera. I guess that's all I can tell you. So that's why there's all these cameras here. So you can click on this. It's on demand. So if you, by chance, I know it's very rare, but if by chance you don't get to class, you could always follow up later. It's also on a vernier, a sliding scale. So if there's one section of the lecture that I went a little too quickly for, you can say, gee, if I could just see that 5 minutes, you can click on, zoom into that 5 minutes, play it a few times, and then say, I still don't know what he's talking about. And then you go to the recitation instructor. So this is what happens. If you go to the website, there's all those bars down the side. So there's lecture videos. There's the lecture topics. That's where the readings are. And there's a whole bunch of other information there and a list of recitation instructors. So here's the reading. So for example, today there's a vision statement, administrative details, and I'm going to get to a little bit of teaching towards the end. And if you wanted to, you could crack the book and look at chapter 1. So that's the drill. But again, that's up to you. A couple of topics, a little bit unpleasant, but we have to cover them. This is where the management doesn't care what I say in terms of chemistry, but they really care about this stuff. So I'm going to obey. So academic honesty. Very simply, you can't cheat in 3091. Is that shocking? No cheating. You know this. The Roman poet, philosopher Juvenal said, men need not so much be informed as reminded. You know this. I'm telling you nothing new. So, when you take a test, you don't accept information from others. You don't represent as your own work the work of anyone else. And you don't use aids to memory other than those permitted by the examiner. I'm giving you an aid sheet. You got the table of constants. What else do you need? It's enough. And following a test, a lot of people write in pencil. Don't try to erase something and bring it back and say that, oh, actually, this is what I had. Because, we look at that and go, how? This is perfect. How did we miss something like that? Don't do that. And also, we're trying to teach you on many levels. We're trying to teach you some chemistry, but also trying to teach you how to transform into a standalone professional. And the code of conduct, professional conduct that we embody by this code here is comparable to what you are expected to adhere to in your professional lives. You don't publish results that you faked. You don't publish results that you stole from others and represented as your own. So don't start here. And, it happens infrequently, but I got to tell you, a few years back, on the final exam, a couple of people were involved in passing information back and forth. They got caught. You know why they got caught? Because for the first time, you're being taught by people who are as smart as you are. So you're going to get caught. My TAs are really smart. So don't think it's like back in picket plates. I could offend somebody. It's not like we're back in Ontario. How's that? That's where I came from. Okay? You're here now. So don't try it. You're going to get caught. These guys got caught. I had to press the case to the Committee on Discipline. One of them did not return for his sophomore year. That's a crazy thing to do. It's a huge price to pay in a pass-no-record first semester class. And you know who is most severe on the Committee on Discipline? It's made of faculty, administrators, and students. And guess who the most severe members of that committee are? It's the students, your peers, who are outraged at that kind of behavior. Speaking of behavior, I have to maintain a fertile learning environment in here. We've got round numbers in excess of 400 people sitting here. So I expect certain things here. And that's how we're going to get along. First of all, no conversations, no talking. A little conversation here, a little conversation there, it adds up. Okay? So I insist, no talking. Please, no food or drink. No food or drink. We're seated cheek to jowl here. I don't want somebody opening up a clamshell with some hot food in it. It's not right. It's not right. Plus, there's all kinds of trash left around. Nobody picks up this stuff. Now, this is an exception. This is for medicinal purposes. It's to make sure that my throat doesn't get dry. And I swear it really contains Fresca. And, of course, no disruptive behavior. No disruptive behavior. Wireless communications devices must be silenced. Okay? So, from this moment forth, I heard some stuff go off earlier, but I let it slide because I haven't had my chance to explain what my expectations are. But from this moment forth, cell phone goes off, you're out. You leave the room. Okay? And Lord help you if a cell phone goes off during an exam, because those things have text messaging capabilities. If your cell phone goes off during an exam, I come up there, I grab your paper, I tear it in half, and I give you a 0. I am teaching you professional behavior that's unprofessional. You can say that I'm over the top on this. I got 450 people here. I want to maintain a fertile learning environment. When you walk through that door, it's an act of free will. It's an act of free will. Somebody's leaving. Bye. Let's go. Let's get it started right now. Please. It makes noise when you turn it on? You owe these gals dinner, I tell you. All right, turn them off. If they have to make noise as you turn them off, turn them off. But that's it. So, when you walk through that door, it's an act of free will. And we enter into a contract, okay? You walk in here, you have certain expectations of me. You expect me to conduct myself professionally. You expect me to respect you. You expect me not to use foul language. You expect me not to say offensive things to you. You expect me to have a well-prepared lecture. Well, you know what? I have expectations of you. I expect you to come to class prepared. I expect you to sit there quietly, respect your neighbors. I expect you to contribute to the learning environment. That's not unreasonable, is it? Good. Oh. You ever look in the course bulletin? You ever wonder what this is? This is the listing for 3091. 507. 507. 5 hours is contact time. That's 3 hours here and 2 hours with the recitation instructor. 0, there's no lab. 7, I wonder what the 7 is. That must be the time you spend in preparation, in studying. So I make a pledge. You give me 7 hours a week, you will pass this class. Not just by the skin of your teeth, you'll pass it. If you don't give me 7 hours a week, I don't know what I can do for you. So I want you to be successful, so I put this up. This is sort of venues for learning, recitation, reading, homework. So that's my responsibility, the lecture. Recitation, that's got to be the staff. You're responsible for the reading. You're responsible for the homework, the quizzes, the tests, the final exam. Okay. So what we have here is a partnership. We have a partnership in learning. So what we want is for you to grow. Franklin said, education is what remains when you've forgotten all your schooling. So we want you to have some retention here. So we've got a few minutes here. I don't want to just have you go from room to room with people saying, welcome to MIT. So I want to talk a little bit about taxonomy, classification, nomenclature. And I said at the core blitz that one of the things I'm going to try to do is introduce some things from beyond chemistry. So let's see what the Bard had to say about nomenclature. There may even be people here who distinguish themselves because they starred in Romeo and Juliet, or maybe they produced, maybe they built the sets, maybe they wrote the screenplay. I don't know. So let's look. Act 2, Scene 2. You remember this? Romeo. But soft, what light through yonder window breaks? It is the east, and Juliet is the sun. That has nothing to do with nomenclature. Nothing. Photon emission, perhaps. Okay, let's get to nomenclature. Juliet. O Romeo, Romeo, wherefore art thou Romeo? Deny thy father and refuse thy name. Or if thou wilt not, be but sworn, my love, and I'll no longer be a Capulet. See, she's a Capulet. He's a Montague. You know, like the Hatfields and the McCoys, the warring families, two lovers. You know, it's as old as literature. It's here. Okay. So now, Romeo. Shall I hear more or shall I speak at this? Fellas, bit of advice. Don't interrupt. The answer to that question is no. Don't speak. Okay. So, Juliet, 'tis but thy name that is my enemy. Thou art thyself, though not a Montague. What's Montague? It is nor hand, nor foot, nor arm, nor face, nor any other part belonging to a man. Oh, be some other name. What's in a name? That which we call a rose by any other word would smell as sweet. So Romeo would, were he not Romeo called, retain that dear perfection which he owes without that title. Romeo, doff thy name, and for that name, which is no part of thee, take all myself. That's an offer. In science, it works differently. In science, we have to agree. It can't be like Alice in Wonderland. I'll give the word the meaning I intend it to mean. Science has to have some rigor. So if you look in Chapter 1, you will find these definitions for different atomic groupings, starting down here with the elements and moving through, up through complex matter. This is solid state up here, aggregates of atoms. So we're going to begin down in the lower left corner. We're going to begin in the lower left corner. So let's look at some of the origins of chemistry. We can go back to ancient Egypt, where there's reference in the hieroglyphs to a term, chemia, which, among other things, meant chemical processes for embalming the dead. You know, the Egyptians were very concerned about afterlife. They wanted to be well preserved to make that journey. And so practitioners who understood what? what we would know to be chemistry, were highly valued in that society. And then chemia expanded to other chemical processes, dyeing of cloth, glass making, and metals extraction. It's magical. It's sorcery to take an ore and convert it to metal. It's magic. It still amazes me today. Gee, you know, I showed you this earlier. One of my areas is extraction of metals. Extraction of metals. You know, some things never change. And then they tried to make an overarching theme to go to the heavens. So there were 7 known metals at the time and 7 heavenly bodies. So obviously the sun would be gold. Mercury is a liquid metal, and Mercury, the planet, is the fastest moving naked eye heavenly body. Mars, iron. Why is Mars red? Iron oxide. And in fact, you could even couch things. So if I wanted to make a bronze, which is an alloy of tin and copper, I could say the confluence of Venus with Jupiter. And that way keep it so that the common folk would know the secret of the alloy. So now let's look at the transition from craft to science. Craft to science. About 2,400 years ago, we have Democritus. And Democritus moves from practice to theory. And this is all that was known at that time. 7 metals, carbon, and sulfur. And so here was his idea of the structure of matter. It's about 400 BC. And what did Democritus do? He described the physical world as the integral of void plus being. Void plus being. He used lofty terms. And being, he described as an infinity of indivisible particles. Indivisible particles, which he dubbed atoms. From the Greek, to me means to slice, and a as in apolitical, amoral. So a, to me, is something that is indivisible, cannot be sliced. And he says these are eternal. And in between, there is void, which is very similar to how we would describe vacuum. This is 2,400 years ago. This depiction of matter takes you right up to E equals mc squared. Brilliant. And that's all he had to work with for data. That's all he had to work with. But science doesn't always move forward. After that came Aristotle. And Aristotle gave us this system, which persisted almost through the Middle Ages. And Aristotle gave us this. And I'll leave you with this, and you can ponder. So this is the Aristotelian view. He's got 4 essences: earth, fire, water, air. You can even make compounds. Earth plus water makes cold. I mean, this is nuts. This is nuts. All right? But it was there for over 1,000 years, and we now know things to be a little different. And so what I'm going to do next day is return to this discussion and take a look at a more rational view of the chemical world. So we'll see you on Friday.